Have you ever noticed that some phenomena in the universe are just too strange, so strange that they almost defy the physical laws we know? For example, a satellite that was not made by anyone has been orbiting the Earth for hundreds of years. A star that lacks iron, but contains a large amount of radioactive elements that should not be there. Or even, some scientists have begun to suspect that we might be living inside a black hole, and this is just the beginning. You may have never seen the collective rotation of galaxies captured by James Webb, nor heard about the radio signal received by Tesla, and you probably have not realized that the star about to devour everything is already aimed at Earth. So in the next 30 minutes or so, we are going to re-examine these anomalies and unravel a series of seemingly unrelated mysteries to ask one question: is the universe really as simple as we think it is? Section 1. A star of unbelievable size. How big can a star get? Big enough to make our sun look like a tiny speck of dust by comparison. If you can reach the vicinity of WOG-64 and find a planet orbiting it, perhaps you could personally experience the awe of being enveloped by a stellar giant beast. WOG-64 is a red supergiant star. It is located in the Large Magellanic Cloud, which is a satellite galaxy of the Milky Way. It is not very far from us. Red supergiants like WOG-64, they are not uncommon in the large and small Magellanic Clouds. They provide astronomers with an important window to test whether our current theories about massive star evolution are reliable. And among these red supergiants, WOG-64 is likely the largest one known so far. It is not just big, it is a true giant of the cosmos in every sense, and its whole body is emitting an unusually intense light. How big is it exactly? We can compare it to the Sun. The radius of WOG-64 is about 1,540 times that of the Sun. What does that mean? It is like comparing a grain of sand to a basketball. A tiny particle that is almost invisible on the ground, compared to a ball you can hold in your hand. If you put WOG-64 in the position of the Sun, its surface would extend all the way past Mercury, Venus, Earth, and Mars, finally reaching beyond Jupiter's orbit. Keep in mind, Jupiter's orbital radius is about 1,000 times that of the Sun, and Saturn's orbit is 2,000 times that. The radius of WOG-64 falls right between the two. It is about 1,500 times larger. Even more extreme is the fact that it has a massive dust envelope surrounding it. If you were to fully spread out this envelope, its coverage could even reach 1 light-year across. That is equivalent to 5.88 trillion miles. WOG-64 is not only enormous in size, but also incredibly bright. It is one of the brightest stars we know of so far. Total energy it releases every second. It is 282,000 times brighter than the Sun. Even more astonishing is its unbelievably thick cloud of dust. As early as 2007, scientists using the Very Large Telescope discovered that WOG-64 is surrounded by a massive ring-shaped cloud. The dust is so dense that it even blocks the star's own light. This dust is not from outside. It is actually expelled by the star itself. Its total mass is roughly equivalent to 3 to 9 suns. It is like slowly dismantling itself into a mist that covers the sky. As for the name of this star, WOG-60, it was not chosen at random. It comes from the initials of its 3 discoverers: Bengt Westerlund, Olander, and Hedin. They were the first to identify this star in the 1970s. By the way, Westerlund also discovered another very special red supergiant, Westerlund 126. It is hidden in a massive star cluster in Ara called Westerlund 1. Let us turn our attention back to WOG-64. Scientists have found its size is already approaching and may even exceed a boundary called the Hayashi limit. The so-called Eddington limit is the theoretical maximum radius a star of a given mass can reach. Once it crosses this critical point, the star enters a highly unstable state. On one hand, gravity pulls inward from within, while on the other, the radiation pressure from the outer layers pushes outward. It is like a tug-of-war. One wrong move, and it could tear apart. And WOG-64 is right at the edge of this critical limit. Density is extremely low, but its radiation pressure is extremely high. Combined with the opacity of fusion products, it can no longer hold onto its atmosphere. Therefore, its mass is being lost at an unprecedented rate. Among all the red supergiants we have observed, its mass loss rate is one of the highest. It also exhibits a rather rare feature, a special nebular emission spectrum. The hot gas inside it is rich in nitrogen, and the radial velocity of these gases is actually faster than that of the star itself. This is an extremely rare phenomenon. Even more interesting, scientists also suspect that it may have a companion star, an O-type main sequence star. If this is confirmed, WOG-64 would be classified as a binary system. But for now, it can't be verified because that thick cloud of dust makes observation almost an impossible task. In any case, Ward 64 is fascinating, not just because of its size and brightness, but even more so because of that ever-evolving, constantly erupting, mysterious dust envelope. It is often these kinds of unconventional exceptions that mark the true starting point of scientific progress. The things we can't explain are often the ones most likely to change our understanding of the universe. Section 2. The way a star dies is far stranger than you think. Is it really possible for a planet to be bigger than its parent star? If you are talking about a star like the Sun, then it is almost safe to say it is impossible. But if you are talking about a white dwarf, that is a different story. What is a white dwarf? It is the remnant left behind when a star similar to the Sun reaches the end of its life. When a star runs out of fuel, it throws off its outer layers of gas, leaving only the core. This stripped bare core is the white dwarf. Its volume is usually only about the size of Earth, or even smaller. Before that star died, there was a planet even larger than Earth, and that planet just happened to survive all the destructive chaos. Then, it really could end up larger than the white dwarf. It sounds a bit crazy, but we have actually discovered such planetary systems. But it is worth noting here, a white dwarf is no longer a real star. It no longer undergoes any nuclear fusion or produces energy. It is like a piece of still warm coal cinder in the universe, just quietly sitting there, slowly cooling down. Strictly speaking, though such a planet is large, the parent star it orbits can no longer really be considered a true star. If we bring the standard back to active stars like the Sun, the situation is different. The Sun is constantly at work. Its core is fusing hydrogen into helium. It has been doing this for over 4 billion years, and it will keep working for another 7 to 8 billion years. The Sun's diameter is about 10 times that of Jupiter, the largest planet in the solar system. Unfortunately, at this scale, it is almost impossible for a planet to turn the tables, because if you keep adding mass to a giant planet, its own gravity will compress it, making it smaller rather than bigger. In theory, it is impossible. You can't find a planet that is bigger than a star like the Sun. But let us look at a more subtle example. Red dwarfs. Red dwarfs are the smallest mass stars known so far. Their mass is just enough to reach the lower limit for core hydrogen fusion. Astronomers have recently confirmed some extremely small and faint red dwarfs. They are almost at the minimum threshold for sustaining fusion. To reach this threshold, it is about 75 times the mass of Jupiter. Although these little guys are genuine stars, their size is extremely small. Some are even smaller than Jupiter. One of them is only the size of Saturn. So does that mean that it is possible for a star to actually be smaller than its own planets? Theoretically, yes. But in reality, such cases are almost never observed. We have already detected many exoplanets, which are worlds orbiting other stars. These planetary systems do indeed display a wide variety of characteristics. Their masses vary greatly. Their brightness, density, and structure are all vastly different, but overall, giants are rarely found in red dwarf systems. Orbiting red dwarfs. Most planets are small rocky ones, more like Earth. These are what we call terrestrial planets. For example, a red dwarf star called TRAPPIST-1 has 7 Earth-sized planets orbiting around it. But giants as massive as Jupiter are extremely rare around red dwarfs. How rare? According to current observations, out of every 100 red dwarfs, maybe only one can show off a giant of its own. And this number might even be overestimated, because the current data still includes many unconfirmed candidate planets. What is even trickier is, the smallest red dwarfs are often also the faintest. This makes them extremely difficult to observe. It is already hard enough to figure out whether these dim stars are planets at all, and to further confirm whether these planets are giants like Jupiter, or rocky worlds like Earth. It becomes even harder. So these systems are not non-existent. They are just so rare they are hard to detect. Do not forget, even though red dwarfs are small individually, their numbers are astonishing. In fact, they are the most common type of star in the entire Milky Way. They make up over 70% of all stars. Even the smallest subset of red dwarfs is extremely rare. But there are still millions or even billions of them in the galaxy, so even if only a tiny fraction of them have giants. In terms of total quantity, systems where planets are bigger than stars are indeed still possible. Maybe somewhere in a corner of a galaxy you have never thought of. Such a counterintuitive world quietly exists. Section 3. There may be invisible stars hidden in the universe. Recently, the James Webb Space Telescope made a discovery that no one expected. It may have captured a new type of star born in the early universe, and what is most astonishing is that this star might actually be powered by dark matter. No, Throughout the entire universe, about 84% of matter neither emits nor absorbs light. We can't see their existence, nor can we directly measure them. Scientists call this kind of invisible, intangible, but there is a mysterious presence that can influence everything. It is called dark matter. It is like the invisible skeleton of the universe. It affects the formation of galaxies and the propagation of radiation, and may even determine the overall structure of the universe. Uncover its true nature. Scientists have been searching for so-called weakly interacting massive particles, which may be the fundamental building blocks of dark matter, but so far, all the detectors have found nothing. Some studies have even suggested that dark matter might be like strands of cosmic hair streaming outward from Earth in the form of tiny particle flows woven throughout the entire universe, but none of this has been confirmed yet. And now, all attention has returned to an even older hypothesis. The so-called dark star. This type of star is completely different from the Sun as we understand it. It does not burn through nuclear fusion at its core. Instead, it might be powered by interactions of dark matter. The term dark star was first proposed in 2007. It describes a type of celestial body that may have formed at the very dawn of the universe. To this day, we have never actually observed their existence, but that has not stopped scientists from believing that they really did exist. They might even still exist somewhere on the distant edge of the universe, according to theoretical predictions. Dark stars may have formed in clouds of gas made up of hydrogen and ammonia. These clouds absorbed an excess of dark matter, and when dark matter particles collided with each other, they might have undergone annihilation reactions, releasing enormous amounts of energy. This energy not only emits light and heat, but can also prevent the gas cloud from continuing to collapse. This avoids the formation of the dense stellar core we are familiar with. If the collapse process does not occur, the dark star can keep expanding. Its volume grows larger and larger, at least in theory. The diameter of a dark star could be 10 times the size of Earth's orbit. Its size and mass far exceed the limits of what we know. Its mass could be millions of times that of an ordinary star, while its brightness could even reach billions of times that of our Sun. This might be the real reason why the James Webb Telescope can see them. To verify this possibility, scientists carefully studied early universe images captured by the Webb Telescope. In those photos, they found more than 700 extremely distant celestial objects. These objects may have appeared within just 100 million years after the birth of the universe. It happens to be the theoretical time window for the birth of dark stars. These lights from the distant past have already been stretched by the expansion of the universe, creating the phenomenon known as redshift. Therefore, the research team specifically selected 4 of the extremely redshifted targets as key subjects for analysis because these celestial bodies are among the oldest objects in the universe we can currently observe. They might be small galaxies that just formed in the early universe. They could be dark stars. Unfortunately, even the most advanced James Webb Space Telescope still does not have high enough resolution to distinguish whether these ancient light sources are galaxies or just a single supermassive star. The truth remains to be seen, but if even one of these objects is confirmed to be a dark star, that would mean, for the first time, we would witness how dark matter shaped the dawn of the universe. Ignite a star. Episode 4. The universe is only 13.8 billion years old. So how can its radius be 46 billion light years? Look up at the night sky. Pick any direction and gaze into it. Light there may have already traveled across billions of years of space and time, and the oldest light we can observe today was actually emitted 13.8 billion years ago. That is, the very moment when the Big Bang occurred. But what comes next might sound a bit counterintuitive. These ancient rays of light, by the time they reach Earth, the information they carry actually comes from a place now about 46.1 billion light years away from us. Why is that? Because the universe itself is constantly expanding as light travels through space. Space itself is stretching, so the light from 13.8 billion years ago that we see today actually comes from a distance far greater than 13.8 billion light years away. Moreover, as time goes on, light from even more distant galaxies is still on its way to us, so the range of what we can see is constantly expanding. But at any given moment, there is an invisible and intangible boundary that is the limit of the observable universe. This means that at any point in the universe's history, its size has never been infinite. It expands as time goes on. When the Big Bang had just occurred, it was much smaller than it is today. So here's the question. If we rewind the timeline all the way back to the very beginning, which is the starting point of the Big Bang, what would we see? Is it an infinitely dense, infinitely hot singularity? Actually, it is not. The real theory suggests that moment would not be a mathematical point. Instead, There is a limit. There may have been a smallest size in the history of the universe. Why must this limit exist? To answer that, we have to start with the rules that govern the universe. If we want to understand what the universe will become in the future, or how it evolved in the past, we need to figure out its underlying logic. And all of this logic is written in one great theory. General relativity. It tells us that gravity actually comes from the curvature of space-time. The universe also has two very crucial properties. Isotropy, which means it is the same in all directions, and homogeneity, which means that in different locations, its state is also roughly the same. The combination of these two properties means that if the universe is to maintain this kind of symmetry, it can't be stationary. It has to be constantly expanding. In the early stages, it must have experienced contraction, and once you know its current rate of expansion, you can deduce its size and density at any point in the past, as well as predict its possible future trends. You can even infer how different components of the universe, for example, radiation, ordinary matter, dark matter, neutrinos, and even dark energy have all changed in importance during different periods. These ingredients of the universe are not fixed forever. Instead, they transform and change over time, and even their primary roles keep shifting. There is a theory called cosmic inflation. It suggests that before the Big Bang, the universe once went through a period of extremely rapid expansion. At that time, space was filled with an enormous amount of energy. This energy was similar to what we understand today as dark energy, but much stronger. After this period of inflation, which may have lasted indefinitely, ended, this energy began to transform into matter and radiation. That was what truly triggered what we now call the Big Bang. In other words, the Big Bang was not the beginning of the universe, but a turning point. Let us return to the question of the size of the universe. According to the latest estimates, in the 13.8 billion years since the Big Bang, the diameter of the universe has expanded to about 46.1 billion light-years. When the universe was only about 10,000 years old, its diameter was roughly 10 million light-years. By the time it was 3 years old, its size was roughly equivalent to our present-day Milky Way. If we go back even further, when the universe was only 1 year old, it was already hot enough for nuclear fusion to begin inside. And if we go back to when it was just 1 second old, the temperature was too high for nuclear fusion to occur. Its radius was only about 10 light-years. That is just enough to encompass the 9 star systems closest to our Sun. If we managed to observe the universe at an even earlier stage, for example, at just 1/1,000,000,000 of a second after its birth, what we would see is a universe only as large as Earth's orbital path. The entire universe was once compressed within the diameter of Earth's orbit around the Sun. This is the most astonishing true history of the universe we live in today. Section 5. The fate of a star is determined from the moment it is born. Take a look at this scorching little monster in the universe, a white dwarf. Do not be fooled by its small size. It is a notorious interstellar grinder. It pulls in any object that comes too close, shredded, crushed, and ground down, eventually reduced to cosmic dust. It is like throwing a planet into a giant coffee grinder. Sounds like a joke, but this could very well be the fate of the solar system. A white dwarf is what a star becomes at the end of its life. It used to be an ordinary star like the Sun. After burning out, it sheds its outer layers. Only a core of extremely high density and intense heat remains. Its volume is only about the size of Earth, but its mass remains almost unchanged. Its gravity is so strong it could crush a planet into a sheet of metal. Scientists predict that when the Sun evolves into a white dwarf, Earth won't live to see that day. It will be swallowed up long before the Sun becomes a white dwarf. Mars, the asteroid belt, and even some of Jupiter's moons, they will have their orbits disrupted after that, and eventually fall into this interstellar grinder, where they are completely crushed. A 17-year-long observational project has provided direct evidence for this doomsday scenario. Scientists monitored the transit events of 3 white dwarfs, which is when an object passes in front of a star, briefly blocking its light. Through these changes in brightness, they can determine the size, shape, and distribution of these objects, as well as the entire process of them being consumed. The results are astonishing. These passing celestial bodies, be asteroids, moons, or even fragments of planets, not only are their shapes bizarre, moreover, the transiting stars are extremely unstable. This suggests they are being further torn apart and consumed. One of the white dwarfs, around 2010, seems to have experienced a catastrophic event. Its transits went from stable to chaotic. Another white dwarf suddenly dims and brightens every few months. The third one's behavior was relatively normal at first, but then the transiting phenomenon suddenly disappeared. It was as if the fragments were swallowed up in an instant, leaving no trace behind. This made scientists realize that the environment around white dwarfs is even more chaotic than they had imagined, and these observations also hint at what the true end of the solar system might look like. But the story does not end there. Recently, scientists discovered a white dwarf with mysterious metallic scars. That mark might be the bite mark left after it devoured an asteroid. Generally speaking, it is not unusual to find metals in the atmosphere of a white dwarf. It is because material pulled in by gravity contaminates its surface. But what is special about this star is that the metal patches are concentrated in one area, instead of being evenly distributed. Even stranger, it is located right at one of the magnetic poles. As the star rotates, this spot periodically blocks part of the starlight, a cosmic tattoo. Researchers speculate this may be the result of a strong magnetic field guiding where metals settle. Much like Earth's auroral zones, charged particles flow along magnetic field lines and deposit in specific regions. The asteroid it consumed was probably only about as big as Vesta in our solar system, the diameter of just a few hundred kilometers. But its remains are now clearly exposed on the surface of the star, serving as an excellent sample for us to study the composition of exoplanetary bodies. Ironically, its destruction actually makes it easier to study, and this is not an isolated case. Scientists have already discovered two white dwarfs that may also bear similar metal scars. White dwarfs, the scars on these star gluttons, might be a new window for us to understand the end-stage behavior of stars. What is even more astonishing is scientists have also discovered another shocking anomaly in white dwarfs. Some white dwarfs actually stop cooling after death. This is not a system glitch, it is that they truly stop getting colder. Moreover, some of these stars stuck in a hot state have been stalled for over 8 billion years. This seriously challenges the theory of stellar aging, because in theory, once a white dwarf stops fusion, it should only slowly cool and disappear. But new research has found that the plasma inside a white dwarf forms crystals with a lower density than the liquid. During the cooling and solidification process, these crystals float upward and push heavier material toward the center. This process of inward settling releases gravitational potential energy, reheating the star. Just like that, a star that was supposed to die suddenly seemed to get a second life, shining brightly for several 100 million more years. This not only disrupted our understanding of the stellar life cycle, also threw the white dwarf dating method into crisis. In the past, we believed that the colder a white dwarf was, the older it must be, but now we know some white dwarfs just have not cooled down yet. Its actual age might be billions of years older. This also means that if we want to deduce the history of the Milky Way through white dwarfs, probably need to figure out first whether they have secretly been cheating or not. Section 6. Betelgeuse suddenly dimmed and scientists were shocked. There are countless stars in the night sky, but among them, there is one that can not only be seen with the naked eye, and it is standing right at the doorstep of a cosmic explosion show. It is called Betelgeuse. Just find the 3 bright stars on Orion's belt. Then look to the left. That giant, reddish bright star is the one. Is only 640 light-years away from us, practically a neighbor in cosmic terms. But its origins are far more legendary than you might imagine. Was once a blazing blue-O-type star, with temperatures reaching 50,000 degrees Celsius, hot enough to vaporize metal instantly. But that kind of brilliance could not last for long. It burned through its hydrogen fuel and began to evolve into a red supergiant. As a result, its size started to swell dramatically. Now it is 1,000 times larger than the Sun. If it were moved to the Sun's position, it would engulf Mercury, Venus, Earth, and Mars. Even Jupiter can't escape. Its outer atmosphere can reach as far as Saturn's orbit. But what surprised astronomers even more is that its behavior is becoming increasingly strange. The first odd thing is that its rotation speed is too fast. A massive star like Betelgeuse should move slowly, like an elderly person. But it is spinning at a speed of 3 meters per second, as if it is practicing a cosmic square dance. One theory suggests it may have swallowed another star. Another viewpoint believes that the telescope has simply been fooled by the star's violent surface bubbling. These bubbles are enormous, bigger than Earth's entire orbit. They burst out from inside the star, churning violently. They are even faster than a spacecraft. Through the telescope, one side appears to be approaching, while the other is receding. This might just be an illusion caused by the boiling of the cosmos. But things did not stop there. What really got people's hearts racing was the great dimming event of 2020. Betelgeuse suddenly dimmed by 2.5 times, far more dramatically than its normal cyclical changes. And this discovery was actually made thanks to a weather satellite designed to monitor the weather. Its change was so unusual that some scientists even began to wonder. Betelgeuse, is it about to explode? You heard that right. Betelgeuse could very well be the next supernova to explode in our galaxy. According to the model, a massive star exhausts the fuel in its core. It burns in layers: hydrogen, helium, carbon, oxygen, silicon, all the way up to iron. But iron no longer releases energy. Instead, it absorbs energy. The core collapses instantly like an engine losing power, triggering a cosmic-scale explosion. This is known as a core collapse supernova. It would be the most spectacular cosmic fireworks show imaginable if Betelgeuse explodes within our lifetime. It will be brighter than a full moon, bright enough that you won't need a lamp at night, and you could read at your desk by its light, and during the day, its brightness could even create a visible point in the sky to the naked eye. It would be the first true supernova spectacle in the Milky Way in the past 400 years. But the question is when exactly. Some studies suggest Betelgeuse may currently be in the carbon-burning phase. The most intense stage has not started yet. If it is just beginning, we might have to wait another 1,000 years. If it is in the final stage, then it could explode within a few decades. Another study suggests it may have less than 300 years left. This conclusion comes from its pulsation patterns. The rhythm of its expansion and contraction reveals its age much like a heartbeat. There are even ancient records noting that people described it as yellow in ancient times, rather than the red we see today. If that is true, it means its evolution is not finished yet. So the answer is nobody knows. It could explode tomorrow, or it might not happen for another 1,000 years. But do not worry, even if it exploded right now, we would still be completely safe, even though it is relatively close to us. There is still a safety buffer of about 100 light-years. Betelgeuse is 640 light-years away from us. Just outside that zone, the high-energy radiation from the explosion won't affect Earth, so you can relax and look forward to this visual spectacle, one of the greatest cosmic shows you might witness in your lifetime. And right now, it is quietly counting down. The chemical makeup of this star in Section 7 is just too strange. We thought stars in the universe were all pretty similar. Just some are hotter, some are cooler, some bigger, some smaller. Some stars just do not follow the usual rules, as if they come from a different set of physical laws. Take Przybylski's star, for example. It was discovered back in the 1960s, but even today, astronomers still can't figure out what it is really about. First of all, its chemical composition looks like an alien's shopping list. It contains all kinds of extremely rare elements, and even some that should not exist on Earth at all. Elements like strontium, cerium, and even two mysterious elements that have not even been named yet. And these strange elements, not only can it not be produced by any known natural process, but its iron and nickel content is actually only 1/10 that of the Sun. Even more astonishing, its rotation speed is incredibly slow. It takes nearly 200 years to complete one rotation. And you think that is strange enough. There is something even weirder. An app star takes 1,000 years to complete one rotation. The rare elements in Przybylski's star, some say, might come from its invisible companion star. For example, a neutron. Some people have made even bolder guesses. It might be evidence of some kind of alien technological activity. The spectrum is so densely packed with chemical indicator lines that even experts are amazed. But what is most puzzling is that it also contains high levels of radioactive elements. In theory, these should have decayed away within a few thousand years, but this star is already 1.5 billion years old. Why are they still there? One explanation is its extremely slow rotation and strong magnetic field bring internal elements up to the surface. Another, more far-fetched guess is that these radioactive elements might be decay products of some unknown super-heavy element. But so far, no one has been able to prove either theory, and it is not the only star shrouded in mystery. Another cosmic weirdo is called Tabby's star. Bobby's about the same size as the Sun and is roughly 1,500 light-years away from us. But what is most unusual about this star is that it mysteriously dims. Sometimes it dims by 5%, sometimes by 22%, and this can last for days before returning to normal. You know, even a planet as big as Jupiter passing in front of a star would only cause its brightness to drop by 1%, and planets move in regular orbits. But Tabby's star dims with no pattern at all. Some people guess it is being blocked by a cloud of dust. Others say it is the result of a moon orbiting the star disintegrating and exploding, with debris forming unstable orbits and causing the changes in light. There are even crazier theories, like alien megastructures, although the mainstream view leans toward natural explanations. There is still no conclusion. Take SO 06462. For example, young star surrounded by a complete spiral disk structure. It is not a galaxy, it is a disk created by the star itself, and the shape of this disk is actually pulled out by two baby planets that are still forming. As these two little guys grow up, they stir up gas and dust like mixing rods, forcibly twisting out two distinct spiral arms. Moreover, these planets were actually discovered by us with the Hawaii telescope while we were searching for exoplanets. And there are even more extreme cases, such as R104, a Wolf-Rayet star on the verge of exploding. This star has already exhausted its nitrogen and is now burning oxygen, teetering on the edge of explosion, and it is part of a binary star system. Stars exchange matter with each other, resulting in a frenzy of energy that could even trigger a gamma-ray burst, but fortunately, it is far enough from us that even if it explodes, Earth won't be affected. However, some strange stars are almost unbelievably beautiful. For example, take Lucy, a white dwarf star with extremely high density. Scientists have discovered that its core has already crystallized, turning into what is truly a diamond planet. The entire heart of the star is made of diamond structure. Its mass is about 1,000,000,000,000,000,000 carats. This is not a metaphor, it is real crystalline carbon. And it is not just Lucy. Later, several more diamond core stars were discovered. They are about the same size as Earth. Finally, let us talk about Vega. Yes, the brightest star in the summer night sky. It completes a rotation every 12.5 hours. It is spinning so fast that its equator bulges outward. Its poles are much hotter than its equator. This causes a phenomenon called gravity darkening. It looks like a perfect sphere, but it is actually a flattened ball, and this peculiar structure also gives it a unique optical profile through the telescope. All of this shows that the universe is not just a monotonous collection of dots of stars. It is more like a gathering of oddballs, where every star might be hiding a story we can't comprehend, or rather, signals waiting for us to understand. Section 8. The Sun may one day swallow the Earth. We all know the Sun is unimaginably huge. You have probably heard that it could fit 1,000,000 Earths inside, but what you might not know is, research shows that 20% to 35% of Sun-like stars will eventually swallow the planets they once nurtured. Yes, the very star that gives life could also end it with its own hands. And what is even more astonishing is, 1 out of every 4 solar systems has gone through chaotic reorganization. Some planets were even pulled in by their sun daddy and roasted away. Our solar system seems to run in perfect order, with each planet in its place, not interfering with others. But in fact, that is just a miraculous survival. You should know, a giant like Jupiter, if Earth were just a bit closer to it, we might have become its satellite long ago. Do not be fooled by our grape-sized Earth. Jupiter is a basketball, and most planetary systems are not this lucky. Their evolutionary processes are much more turbulent and unpredictable. It is not easy for scientists to study whether stars have really swallowed their own planets. The best way is about observing binary star systems, that is, 2 stars orbiting each other. In these systems, the 2 stars are generally born from the same cloud of gas. In theory, their chemical compositions should be almost identical, but scientists have found that this is not always the case. They studied 107 binary star systems, analyzed the spectra of the stars within them. It turned out that the surfaces of some stars showed large amounts of rocky elements, like iron, silicon, and titanium. These are not elements that should be present in the original stellar gas. Instead, they are more like remnants of planetary crust material. It is just like finding pieces of eggshell in a pot of clear soup. Obviously, that star most likely swallowed a planet. What is even more outrageous is, these planet-eating suns, after swallowing heavy elements, their own rotation can also change and become extremely fast, even to the point of tearing themselves apart, causing chaos in the system. But do not worry just yet, our sun is still pretty mild for now. For the next 5 billion years, it will continue to burn steadily as it does now, but once it enters its old age, the so-called red giant phase, its size will expand dramatically. At that point, it will grow large enough to engulf Mercury and Venus, and Earth will very likely be on its menu as well. Once the Sun is only 900,000 miles away, we will no longer be able to survive. This distance may look far, but it is actually only 4 times the distance from the Moon to the Earth. If that day really comes, Earth's fate will be like being thrown into an oven. Within seconds, global temperatures would soar, ice caps would instantly melt, coastlines would be submerged, islands would disappear, and eventually the entire surface would burn in a sea of fire. Even worse, if intense solar activity were to throw us out of orbit, Earth would lose its magnetic field protection. Cosmic rays would bombard the surface directly. The air would boil, the atmosphere would collapse, gravity would fail, and the laws of physics would no longer apply. It sounds like a disaster movie, But these are things that have actually happened in the universe, and what we are doing now, by observing the chemical spectra of stars, orbital stability, and other clues. They search for systems that have undergone similar fates. Scientists are looking for planetary systems that have maintained orbital stability through billions of years of evolution. We want to see if these systems have also nurtured life, if we can find a planet similar to Earth, stable, moderate, and not consumed by its own sun. Maybe their lives followed an evolutionary path similar to ours. It is just that we still do not know whether those beings ever possessed intelligence, or if they ever looked up the night sky, wondering, are they alone? Section 9. This satellite has no launch record, yet it has orbited the Earth for 100 years. Can you imagine it? There is a satellite in our orbit that no one admits to building. Markings. No launch records. Not even explanation from anyone. It is as if it appeared out of thin air. Yet it has been orbiting Earth for decades. It is called the Black Knight, and its story is far stranger than you think. In 1899, when Nikola Tesla was conducting wireless energy experiments, he accidentally received a set of strange signals. They were not noise, nor were they electromagnetic waves from Earth. Instead, it was a clear, repetitive rhythm from an unknown source. He firmly believed it was a message from space. From that day on, the mystery of the Black Knight quietly became part of humanity's history of exploring the universe. By the 1950s, radio stations around the world began receiving mysterious signals, and the source appeared to be a hidden object in Earth's orbit. It was not a Soviet spy satellite, nor was it part of a secret American project, because at that time, humanity had not truly entered the space age. Moreover, this mysterious object was moving along a non-standard orbit, and could not be classified. Truly shocked the world happened in 1998. During a mission on the International Space Station, astronauts took a photo during the SCI-Fi mission of a strangely shaped black object floating against the backdrop of Earth. It did not match any known spacecraft design, yet it was clearly moving in orbit. Since then, the Black Knight has gone from an urban legend to an open mystery in the field of astronomy. Some say it is a probe placed near Earth by an alien civilization long ago, meant to monitor humanity. Some people believe it is a remnant technology from ancient times. Some even think it is a kind of device sent back from the future, and the most outlandish theory is that it is some kind of astronomical spy, recording every leap of Earth's civilization. Of course, there are also more rational explanations. It might just be space debris dropped during a mission, but this explanation does not hold up under scrutiny. It remains stable in its orbit. Its shape is unique. Even its reflective properties differ from ordinary debris. Every investigation into it only deepens the mystery. The greatest mystery of the Black Knight is not actually what it is, but why the authorities have always kept silent about it. It is like a deliberately erased fragment of history. Or perhaps is an answer humanity is not yet ready to face. It could be an ancient relic, or an echo from the future. The only thing certain is that it is still there, circling around us, as if waiting for the moment when humanity finally awakens. Maybe one day we will really uncover its identity. Or maybe it is destined to remain the unanswerable question the universe has given us. A cold, black observer watching humanity from afar. Section 10. Some scientists suspect that our entire universe is inside a black hole. It all started with the observations from the James Webb Space Telescope. It captured images of some ancient galaxies from the early universe. And shockingly, 2/3 of them are rotating clockwise. The rest are counterclockwise. If the universe were completely random, this directional distribution should be 50/50. Reality is not like that, which may suggest that the universe was not random from the very beginning. This directly ignited a highly controversial theory. Our universe may not have exploded out of nothing. Instead, it might have been born inside a black hole in another universe. This is known as black hole cosmology, or the Schwarzschild universe model. It proposes that our universe is like a baby universe, sealed inside the black hole of another larger universe. The boundary of a black hole is called the event horizon, from which not even light can escape, and the farthest limit we can observe in the universe today is also just like a horizon. The similarity between the two makes one wonder, have we been living inside a giant black hole all along, without even realizing it? An even bolder idea is, every black hole may be nurturing a new universe. When a star dies, its core collapses into a black hole. According to traditional views, everything gets compressed into a singularity. But there is also a theory that suggests when particle density reaches a certain level, a twisting force emerges, caused by structural changes from spinning particles. This twisting force might prevent the black hole from collapsing further, and instead trigger an explosive rebound, which could give birth to a new universe. Our universe may have been born this way. This also explains why the universe appears so flat and structurally complete. If it really was born inside a black hole, then this rebound process would be like the universe's detonator. This theory also puts forward another radical idea. Black holes are not the endpoint of death, but rather a starting point portal. The matter that falls into a black hole might be ejected from a white hole in another universe. A white hole is the opposite of a black hole. You can't get in, but things inside can flow out, and if this model holds true, the rotation axis of black holes in our universe, perhaps this is the starting point of the entire universe's rotation. In other words, the way a black hole spins might directly determine the orientation of the universe it gives birth to. In other words, a baby universe inherits the rotational genes of its parent. Of course, there is another dimensional reduction explanation. Maybe these observed rotational trends are simply because our own galaxy is also spinning, which in turn affects the telescope's observations. But who knows? Maybe one day we will actually be able to prove that the entire universe is the product of a black hole inside another universe, and we are nothing more than a speck of dust floating in a bubble of time after the great rebound. At this point, we might think the story of the universe is a book of answers, gradually revealed, but the deeper we go, the more we realize it is more like a collection of riddles that keeps questioning us. From the death of giant stars, the silence of dark matter, from the rotation of galaxies, to possible universes inside black holes, behind every observation lies a new contradiction, a new imagination, a new unanswered question. Perhaps the universe was never something waiting for us to understand. It simply extends its invitations to us again and again. In its own way, it invites us to question, to explore, to seek answers, even though it never promises to provide them. And the only thing we can be sure of is that we happen to exist in the midst of all this unfolding. Do not be in a hurry to stop asking questions about the universe, because the deepest secrets may not have even begun to show their first cracks yet.